Hey everyone, and welcome back to another explainer. Today, we are looking at something truly incredible. We're going to decode the hidden technology that runs literally every single aspect of our modern lives. Seriously, it's all around you, right now, completely out of sight. We are talking about embedded systems. And we aren't just going to uncover the invisible magic powering your world today. By the end of this explainer, we're going to map out a highly lucrative, completely future-proof career path for you in this exact space. Okay, let's dive into this, because I want to completely shatter this illusion we all seem to have that computers only look like laptops with screens and keyboards. I mean, think about your morning today. Your alarm went off on your smartwatch, you turned on the coffee maker, maybe you threw a load of laundry into a digital washing machine, or drove your car to work. Every single one of those interactions relied on a hidden, specialized computer. So if you thought you only used one computer today, yeah, think again. You've probably interacted with dozens already. Here is our quick roadmap for this explainer. First, the invisible tech around us. Second, what's actually inside these systems. Third, why this field is so critical. Fourth, your potential career. And finally, the ultimate learning roadmap. Let's jump right in. All right, part one, the invisible tech around us. From the smartwatch tracking your heartbeat, to the ATM dispensing your cash, to that drone hovering up in the sky, they are everywhere. But honestly, here is the most fascinating part to me. One single device can contain multiple embedded systems all working together at the exact same time. Take a modern car, for example. The engine control unit, that's an embedded system. The infotainment screen, another embedded system. The anti-lock braking system, or ABS, a highly critical embedded system. A single car can have over 100 of these tiny dedicated computers rapidly talking to each other as you just cruise down the highway. Moving on to part two, inside an embedded system. And this brilliantly illustrates the core concept here. Think about a general-purpose computer, like the laptop you might be using. It's built to multitask, right? You can browse the web, edit a video, play a game, write a document. It's a total jack-of-all-trades. But an embedded system, it's built to do exactly one job and do it perfectly. Think of the microprocessor inside a microwave. It doesn't need to run a web browser. It just needs to read the keypad, manage the timer, and control the radiation perfectly. It is an absolute master of one single task. Which brings us to our formal definition. If we want to get technical, an embedded system is a combination of hardware and firmware designed to perform a specific, dedicated function. I really want you to focus on that phrase right there, dedicated function. It's hardware built for a purpose, brought to life by software, which we call firmware, that is permanently programmed into it to achieve that one specific goal. So what is actually under the hood? It's kind of like a giant puzzle. The absolute heart of the system is the microcontroller or microprocessor. That's the brain. Then you have the firmware. If the microcontroller is the brain, the firmware represents its thoughts and instructions. Next, we have sensors and actuators. Sensors are basically the eyes and ears. They gather real-world data like temperature or speed. Actuators are the hands. They perform a physical action, like spinning a motor. Throw in some communication interfaces to let it talk to other devices, and a power supply, and boom, you have the whole shebang. So the crucial point is how all these pieces talk to each other in real time. Follow the data flow for a second. First, the sensors collect the data from the real world. Second, the microprocessor runs the firmware to analyze that data in literally a fraction of a second. Third, it sends a command to the actuators to perform a physical action. So if a sensor detects your car wheels slipping on ice, the brain analyzes it instantly and the actuator pumps the brakes. That continuous data flow is what brings the whole system to life. Which brings us to part three, why this field actually matters so much. You might be wondering, why not just use standard computer chips for everything? Well, embedded systems offer things that general computers simply can't guarantee: real-time performance, extreme reliability, and absolute safety. Imagine if the embedded system running a life-saving medical device or your car's braking system just decided it needed to run a software update or suddenly froze on a loading screen. Yeah, no way. You can't have that. You need ultimate safety and absolute real-time reliability. Plus, they offer incredibly low power consumption, which is why things like fitness bands can run for weeks on a tiny battery. They are literally the backbone of all smart devices and modern automation. All right, part four, your career in embedded systems. Just consider the sheer variety of roles out there right now. Embedded systems engineer, firmware engineer, embedded Linux engineer, IoT developer, automotive embedded engineer, robotics engineer. I mean, this proves that this isn't some small niche corner of the tech world. It's a massive umbrella of career options. Whether you want to work on the next generation of smart homes, program the brains of industrial robots, or write the firmware for the latest electric vehicles, there is a specialized, high-demand role waiting for you. Now, what's really interesting here is the compelling financial trajectory. Taking the Indian market as a prime example of this global demand, look at how this scales. As a fresher, you're starting at a very solid 3 to 6 lakhs per annum. But notice how rapid the financial growth is as you gain experience. Mid-level jumps up to 6 to 10 LPA. Seniors pull in 10 to 18 LPA. And lead engineers, they are commanding 18 to 35 plus LPA. The financial growth scales directly with your technical mastery. 35 lakhs per annum and beyond. I really want to emphasize this aspirational peak salary for lead roles. It cements a very important fact. Mastering this highly technical, invisible magic pays off incredibly well. Companies are more than willing to pay top dollar for engineers who can guarantee their hardware runs flawlessly. And if you're sitting there wondering if this is just a flash in the pan trend, look at the future scope. Embedded systems are the foundation powering electric vehicles, smart cities, Industry 4.0, the Internet of Things, and Edge AI. As long as the semiconductor industry continues to grow, and as long as we keep demanding smarter healthcare and smarter homes, your skills as an embedded engineer are going to be absolutely indispensable. This is a genuinely future-proof career, for sure. So let's get practical with Part 5, the Ultimate Learning Roadmap. Let's see how this all builds together across a 4-step journey. Step 1 is your absolute foundation. You must learn C programming and basic electronics. C is basically the bedrock language of embedded systems. Step 2, you move into microcontrollers, specifically industry standards like STM32 and ARM architectures, and you apply your embedded C knowledge. Step 3 is where it gets advanced, mastering communication protocols and RTOs, which stands for real-time operating systems. Finally, Step 4, you elevate your entire profile by learning embedded Linux, device drivers, and IoT integrations. But hey, quick warning here. Just reading textbooks, that's not going to get you hired. You must get your hands dirty. Hands-on projects are absolutely essential. You need to actually program a board, make an LED blank, read a temperature sensor, and build real-world applications. You have to prove your skills publicly by building a strong GitHub portfolio and an impressive resume that highlights the physical systems you've actually brought to life. Theory isn't enough. Execution is literally everything. Which is exactly why I am super thrilled to introduce Embedded Hash as the ultimate bridge to get you job ready. They take that exact roadmap we just discussed and turn it into reality. Embedded Hash offers an industry-oriented curriculum packed with practical lab sessions and real-time embedded projects. You'll get hands-on training with embedded C, ARM, STM32, RTOS, and embedded Linux. And honestly, most importantly, you aren't doing it alone. They provide expert mentorship, mock interviews, and dedicated placement assistance to launch you directly into the industry. The invisible technology running our world is only getting smarter, faster, and way more complex. The future is undoubtedly embedded. The immense value of this field is clear. The career opportunities are just vast, and the roadmap is right in front of you. So the only question left is, are you ready to take the first step and build the invisible tech of tomorrow? Thanks for joining me on this explainer, everybody. Keep exploring, and I'll catch you in the next one.